Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Algebra 1 Common Core Regents, problem number 22. If you want to find these exams, they're freely available online. Go to nysedregents.org. Click on the appropriate tabs, and all these tests are freely available. So here's the question. A system of equations is given below. X plus 2y is equal to 5. And 2x plus y is equal to 4. The fact that it's a system of equations, you do need to know that means that this x and this x are the same x, and this y and this y are the same y. So you can't have x be one thing here and a different thing here. That's not what this means. Nor can you have one y here and a different y here. That's not what that means. They're the same y and the same x. They're true simultaneously. Which system of equations does not have the same solution? Okay, so we're going to go through this these systems, but I do have a complaint about the way these questions are written. The test makers could go much more deeply into this type of question without actually making the question much more difficult, but they didn't go very far with it at all, and that complaint on their side is also actually a favor on your side, because it does make it it makes it a lot easier to be able to solve, because what they do is they only modify here one equation at a time. Sometimes they modify both equations, but they modify them independently of each other. So here, choice 1, we're going to check 3x plus 6y equals 15. We notice that that's equation 1 multiplied by 3, which means that it has the same exact solution set. And this 2x plus y equals 4 is just equation 2. So this system is equivalent to the original, and we're looking for it not have the same solution. So that's not the answer. This one, 4x plus 8y equals 20, that's equation 1 multiplied by 4. And 2x plus y equals 4, that's equation 2. This also has the same exact solution set because both of these equations are equivalent to the original. So that's not the answer. This one, x plus 2y equals 5, that's just equation 1. And this one, 6x plus 3y equals 12, that's equation 2 multiplied by 3. So this one is equivalent to equation 2. This one is equation 1, so that's not the answer because they are equivalent. Now this one, x plus 2y equals 5, that's equation 1. And this one, 4x plus 2y equals 12. This one is like the left side of equation 2. Multiplied by 2, and this side is like equation 2 multiplied by 3 on the right side. That makes a totally different set of values that are solution sets to this equation. So this one likely does not have the same solution set. And since we've already verified that the other three systems are fully equivalent to the original, this one is not equivalent to that one. Okay, let's do another example. So this one has a system of equations below. 2x minus y equals 8, and 2x minus 2y equals 1. Which system of equations does not have the same solution? Now, I recommend that you pause the video, try it on your own, and then unpause the video and see if you got the same solution. If you like what we're doing so far, click the like button, subscribe. Highly recommend you subscribe, and let your school friends know that these videos are available. So here's our solution. I recommend that you label these equations 1 and label these equations 2, and we are going to check this answer. So let's see, 2x minus y equals 8 and x minus 2y equals 1. This one, x minus 2y equals 1. This is actually equation 2. And 2x minus y equals 8. That's equation 1. Same system. It's the same exact system. We're looking for does not have the same solution. Okay. This one, negative 6x plus 3y equals negative 24. That's equation 1 times a negative 3. And this one, x minus 2y equals 1. That's equation 2. So both of these are equivalent to the originals. Each one individually is equivalent to the originals. So this is not the answer. This one, 2x minus y equals 8. That's equation 1. And negative 3x plus 6y equals 3. Look at this. This is times -3 on this side, and this is times 3 on this side. So this is probably going to be the answer. Let's see. This one, the reason is, again, the reason here is because you're multiplying by different numbers on the left and the right to generate this equation from equation 2. This one, 4x minus 2y equals 16. This is equation 1 times 2, and x minus 2y equals 1. That's just equation 2. So in fact, each of these individually is equivalent to the original. So this is in fact the answer. So how do we do this to check? And you can do this on your calculator in the following way. Equation 1 says 2x minus y equals 8. And so we're going to solve for y, minus 2x, and you get negative y equals negative 2x plus 8, divide by negative 1, and you get y is equal to 2x minus 8, okay? And in equation 2, you get x minus 2y equals 1 minus x, and you get negative 2y equals negative x plus 1, and divide by negative 2, you get y is equal to, let's see, negative x divided by negative 2 is 1/2 x plus a negative 1/2, okay, and that's y. So now, what is a solution to this system? A solution to the system is solution to the system. Okay, is an ordered pair x, y satisfying both equations simultaneously. Okay, I highly recommend that you take notes. So equation 1 says y equals, excuse me, 2x minus 8. Let's see, equation 2 says y equals 1/2 x minus 1/2. Okay, and I'm going to do zoom standard. That's choice 6. And since a pair xy satisfies both simultaneously, the pair xy has to satisfy equation 1, which means it's on the graph of equation 1, and it has to satisfy equation 2, which means it's on the graph of equation 2. Since it's on both graphs, it has to be an intersection point, and in fact, there's only one intersection point right there. Okay, so that's the solution to this system. Now I'm going to graph the next system, the supposedly correct answer sign. Also, I'll do this one in red. This one, 2x minus y equals 8 is the original. So this one is y equals 2x minus 8. Okay, and then also this equation is negative 3x plus 6y equals 3. So I'm going to add 3x, and I got 6y. Okay, let me circle this so I don't confuse this. 6y equals 3x plus 3. And then I divide by 6. And I got y equals 3 over 6 is 1/2, so 1/2 x. And 6 over 3 is 1/2 plus 1/2. And so that this one is 1/2 times x plus 1/2. And this one's going to have, and then the original equation was this equation 2. So we're going to show just that we get a new intersection point. Oops, and there we go. We're going to get another intersection point. So this is the solution set. Somewhere around here is the solution to this system number 3. So this is in fact the correct answer. So now not only do we have a method of doing this question by comparing the functions to the originals, but we also have another method of finding the solutions by graphing. Okay, and that's really it. That's all you have to do. You could also solve them by elimination. You could solve them by substitution. There's a lot of ways to find the answers, the value of x and y that satisfies both solutions, and then go that way. All right, listen, you can do it. I know you can. Keep working at it. Thanks for watching. I'll stay tuned for the next video starting right now.